Welcome to lesson 9.5, which involves the sum of a geometric series. Last time we did sum of an arithmetic series, so it's kind of the same idea, but in a geometric series we deal with a ratio or multiplying from one term to the next instead of addition. So just like an arithmetic series, a geometric series has a base formula. They use S, which stands for sum. N represents a certain number of terms. So it'll be like the sum of the first 10 terms or the sum of the first 100 terms. And then N would be that 10 or 100. A1, which is our first term, 1 minus the ratio R to the power of N. So only the ratios raised to the power, not the parentheses, all over 1 minus the ratio. So this is our base formula that we're going to use in the problems. When it comes time to put the entire chapter together, you can tell the difference between using an arithmetic series, where it uses the letter D for difference, and a geometric series, which uses the letter R for ratio. Okay, let's try our first example. Example 1A. So just looking at this problem, without any type of directions, I know it's asking me for the sum of a series. I see the sigma symbol, which is how I know it means the sum. My first term, n, is going to be equal to 1, and then going up to the 20th term. So this tells me there are 20 numbers in my series. Okay, so let's write out our base equation again so that we can figure out what variables do I need to plug in and solve this. Okay. It was S for sum of the first 20 numbers. My first term times 1 minus the ratio to the 20th power, because again I'm dealing with 20 numbers in my series, divided by 1 minus the ratio. So I'm going to need two things. I need to figure out what is my first term and what is my ratio. I'll plug those in, and after that I can just type this in the calculator and get the sum of the series. Okay. To get my first term, a sub 1, that's when n is equal to 1. This number down here at the bottom, remember, that's what we're going to use to represent the first term in the series. And because this is an n in my equation, I'm going to take the first number and plug it in for the n. If that number at the bottom happened to be a 5, then to find the first term in my series, I would plug 5 into the equation for n. So we'll do one of those next. This time, n is equal to 1, so I'm going to plug that in. This is the expression to find that first term. 1/2 to the first power. So 4 times 1/2 is 2. That means the A1 term is 2. Now I need to know what my ratio is. My ratio is going to be that value that's changing. I'm multiplying everything by 1/2. just to show you this mathematically, if I were going to do the second term, a sub 2, I'm going to plug a 2 into the equation. 1/2 squared is 1/4, and 4 times a fourth is equal to 1. So if I want my ratio, here's two terms in the series. The first term is 2, the second term is 1. What do I multiply to get from 2 to 1? It's 1/2. So you don't have to do that every time, but just to show you, it's this value. Let me scroll back up here. It's this value right here that's being raised to the power. That's what my ratio is going to be. So really all I have to do is calculate what A1 is, substitute it into the equation. My ratio is given. The n is a 20. All over 1 minus 1/2. Okay, so I'm going to rewrite this a little bit bigger. Give me just a moment. I'm going to pause and rewrite it. Okay, so I have rewritten the formula. That way, what I want to do right now is show you how we're going to type it in the calculator. Because of all of the fractions, probably the easiest thing to do is to change that 1/2 to 0.5. But I want to show it to you as a fraction in case it's ever something that's not as straightforward as 1/2. Okay, so we're going to type in the calculator. Two times 1 minus, and again, you can use 0.5. I just want to show you for some time that it's not just a tidy fraction like 1/2 to the 20th. Close it. You can hit enter if you want to, or if you do divided by, we need to set up either way. You need to put parentheses around the next part. 1/2, and then hit enter. If you do not include this group of parentheses right here, it is only going to divide by 1 and then take that answer and subtract 1/2. Okay. Also, if you don't include this parentheses right here, it's going to do 2 to the 20th power. PEMDAS tells us to do powers before division, so we have to tell the calculator that I want the fraction to be raised to the power, not just the 2. Okay, I'm going to push pause and type it in, and then see what we get. Okay, so I have typed it into the calculator. I did want to show you what I typed in. Here's the first term, 2. 1 minus, so instead of the fraction 1/2, I used 0.5. And I didn't have to use parentheses because, again, calculator follows PEMDAS. So it's going to do this 0.5 to the 20th and then subtract it from 1. And divide it by, and then I just subtracted 1 minus 1/2. So again, I didn't have to worry about parentheses. I could just do 0.5. And the whole thing is equal to 4. Okay, so that might seem strange because it's such a small number for adding a series together. But let's take a look at maybe 4 terms and see what's happening with our terms. here was my original problem. Okay, we did our first term, where I substitute 1. So 4 times a half. 4 times a half is 2. Then I did the second term. 4 times a half squared. And again, I'm just doing this so you can see why the sum is such a small number, which is 1. And let me do one more. A sub 3. 4 times a half cubed. A half cubed is going to be 1/8. And 4 times an 8 is a half. So we know our ratio is a half. So what I want to do is I'm going to write my series horizontally. I have 2 plus 1, which is 3, plus 1/2, so I'm at 3.5. So if I keep cutting each number in half, now I would be at 3.75. And each time I'm adding a smaller amount. And this is a really important point to make with the geometric series. Eventually, I'm going to be adding such a small amount that it doesn't make a big difference. My next term is 1 over 128. That is such a small number. And as I start adding these together, I get closer and closer to 4. The actual answer my calculator said was 3.99999 something. This is called the limit of the series. It means my series is going to get so close to 4 that it is basically 4. So for example, here I just turned my calculator on. When I added the series in the calculator, I got 3.99996,185. So for all purposes, that's 4. And as I keep adding more fractions to it, and my fraction continues to get smaller, this number would then become the 9. And then this number would become the 9. And we'll keep getting closer and closer. So this is called a finite geometric series. Okay. In another video, we're going to do an infinite geometric series and talk about the difference between the two. So coming all the way back up to my final answer, the sum of this finite geometric series with the expression 4 times 1/2 to the n with 20 terms is 4. All right, so if you're good, you can move on and do some of the assignments. I'm going to do another video with another example if you need it. Thanks.